Bismillah ar-Rahman ar-Rahim. Welcome to Tahar Scholar. We are ثلاثاء 28 نوفمبر 2023 or in English Tuesday 28th November 2023. We are still in our series Programming with Matlab, which is an appendix to this module, Appendix A. And this is the fifth practical. In practical 1 and 2, we have introduced the GNU octave and the data type matrix. And in practicals 3 and 4, we have studied the data type string. In this fifth practical, we will see the data type structure and the data type cells. So there will be two parts in this practical. So let us start with structures. What is a structure in Matlab? In Matlab, a structure is actually a container whose elements have a name and a value. We have seen in a matrix, the elements have no name. We access them through indices, through an index or through a row index and a column index. And the value is always a number, a real number or an integer. But here in structure, we access the elements through their name. And the value of these elements can be of any type and of any size. It can be a matrix, it can be a number, it can be a string, it can be a structure itself, or it can be a cell. And we call such elements fields. So a structure is actually a container of fields. Let us see through an example how to build, what is the syntax, the grammar, to build a structure and to access the fields in that structure. So let us go to our directory, Appendix A, and we go to invoice. We use vegetables to show how to build and access our structures. So we go to invoice 1. So this is the application we have done in last practical. We have stored vegetables as a matrix with the name of each vegetable, then in a separate vector the masses, and in another separate vector the prices. But in structure we can actually store the name of the vegetable, its mass and its price in the same structure, in the same container, not separately. How we do that? Let us see here an example. Let us go to command. We use the function struct. So we write struct. Struct means structures. It's a function. And inside the function, you give the name of the field and its value. We are dealing with vegetables. So we name the first field name, the name of the vegetable, and its value, eggplant, the first vegetable, eggplant. It is a string. The value here is a string. The second field, we name it mass, the mass of the field, the mass of the vegetable, and its value is 500 gram. And the third field is the price. We name it the price. So the name is always a string, quoted string. So inside double quotes. Always the first field, name, the second field, mass, and the third field, price. And then we follow it by the value. The value, I think, is let's check, 435. 4.35 ringgit. And that's it. So it goes by pair. The name and the value. The name and the value. The name and the value. We have three fields. And we define them inside the function struct. And we type enter. So we have a structure, the name, the mass, and the price, and the corresponding values. But in general, of course, you do not manipulate, you do not store only one structure, one instance of the structure, but a sequence, a list, an array of structures. So here we can do that. To store all our vegetables, we use also structure, struct, and we write inside the structure the first field, name, and inside braces we write the values, I mean here name, inside the braces the values of each structure. So the first vegetable, we have called it eggplant. This is the first structure. The second, we called it, let us check here. Let us make copy paste. Okay. So the second vegetable, tomato, and comma, not semicolon, then broccoli, comma, and capsicum, comma, and mushroom. So different values for the same field. The first value with the first structure, the second structure, and so on. The first vegetable, the second vegetable, and so on. We have 5 vegetables. So 5 values for the same field. The second field, we add the second field, we use comma, and the name of the second field, we have named it mass. So the mass of each vegetable inside braces, I think here 500, 500, 500, and 500, and the last I think 200. Let's recheck. Yeah, 500, 500, 500, 500, and 200. So the number, of course, of vegetables here must correspond to the number of vegetables in the first field. The number of values for the first field must be consistent with the number of values in the second field. And we finish with the third field, the name of the field, price, and followed inside braces the values. The values are, let's copy them better. So 435 till 1060. And that's it. We close the parenthesis. We have defined our, let's call it. So we are named it vegetables. So this is an array of structures, also called a structure array. And it has 1, 2, 3, 4, 5 structures. The name, the first field has a name, the name of the vegetables, the name of the second field, mass, and the name of the third field, price, and the corresponding values for each structure, for each instance of structures inside the array. We type enter, and we can use size to check how many elements inside vegetables. Okay, so it is like a row vector, but it's not a vector, it is a structure array, because the elements here are structures. You can also use num element of vegetables. We have 5 structures inside vegetables, 5 vegetables. And there is a function called isStruct to check the validity of our variable vegetables. If it is an array structure, yes, true. Or we can also check a given instance, the first element. For example, the first element. Is it a structure? Is it a valid structure? Yes. Or 2 or 3, etc. We can also check the value. Display the value of vegetables. Number 1, the first vegetable. It has a name. The fields will not change. Name, mass, and price. But the value for the first vegetable, name is eggplant, the mass 500, and the price 4.35. And we can check also for the second. Tomato 500, 6.5. And the end, the last vegetable in our structure array, mushroom 210.6. So this is a better way actually to store our vegetables than using different data, different matrices. The names are in a matrix, the mass in another matrix, and the price in another. Here, all the data is in one single object, in one single array, called the structure array. So we can also append other vegetables to this first list. For example, pumpkin and zucchini, or also called courgette. I have copy paste, and this is how we do that. We use concatenation. So vegetables, concatenation inside the square brackets, the old vegetables, the old list, and followed by the new list. It is a structure. It has also 3 fields and 2 values: zucchini, pumpkin, and corresponding prices and corresponding masses and prices. The same format, the field and the values. The field, second field, and the values. The third field and the values. And of course the same number of values for each field. You note here the ellipses because this is a row vector. So we cannot use here a new line or a semicolon. It will become a column vector. We cannot add new rows to a row vector. It will not work. So we are one single. We do not have space to put the structure here in the same line. We cannot do that. There is not enough space. So we use ellipse, or we can, but for clarity, it's better to separate that. But to tell Matlab that it's the same command, or this is the same command, we use ellipses. So when you have a long command and you want to spread it on several lines, you use ellipses. Okay, let's check the size again. Vegetables. We have now 7 vegetables. Let's check the end. Display the last vegetable. It must be pumpkin. We have pumpkin. The last vegetable now is pumpkin, 500 gram, and the price 3.5 ringgit. So we can use 2 utilities, 2 functions to get the number of fields in a structure and the names of those fields. We know them, of course. Name, mass, price are our fields. There are 3 fields, and these are the names of these fields. But there are functions to get that using Matlab. So num fields vegetables will return how many fields there are in each structure. So let's call it n. It will return 3, of course. There are 3 fields. Each structure in the array structure vegetables, each element has 3 fields. And what are the names of these fields? We use field names, function field names of vegetables. And we return it, we store it in U. And in U. This is actually, this is a cell that we will see in the next section. But suffice it to say that it is a container of elements of different types. The elements in a cell have no name. They are indexed like in a matrix, but the value of each element can be of different type and of different sizes. So here there are actually strings. Each cell contains a string. And the contents of the cell array, this is called the cell array. We don't use, when we use like this one, like a matrix, the first element of the cell array, we get the cell, not the content. To get the content, we use braces. This is the content of the first cell. It is name. The first field is called name. The second field is mass. And the third field is string price. So we will study that later in detail, but suffice here to observe that to access a cell, we use parentheses and the index of the element or of the cell. And to access the content of the cell, we use braces and the index of the cell. The content of the cell, number 1, the content of the cell, number 2, the content of the cell, number 3. We have a cell array of 3 cells. Each cell contains a string, the name of each field. So field names always return a cell array, an array of strings. So I mean an array of cells, not an array of strings, an array of cells. Each cell contains a string. Because we cannot store strings of different sizes in an array, it's impossible. Because they are of different sizes, we can collect them only in a cell array. So we have 2 functions to manipulate the fields: num fields to get the number of fields, and field names to get their names. Any structure, not only, of course, vegetables. Then how we, let's clear the console, how we get the value of a particular field. Let's say the first structure, vegetables, the first vegetables number 1, and we add dot and the name of the field. So the content of the field name of the first structure is eggplant, and the content of the second structure, the field name, is tomato, and so on. So you get the structure, the number of the structure, the number of the element in your array, and you add dot and the field name. We can also check the price and the mass. So always to get the value of a field, you have to add dot and then the name of the field. And that's it. But what about all the values stored in the vegetables corresponding to the field name? How we can do that? We do that like this. 2 points. And we get all the names of our vegetables. This is called actually a comma-separated list. A comma-separated list means this is not a container, this is not an array or a cell array. It is a comma separated like this: egg, plant, comma, tomato, comma, and so on. It is a comma separated list. It is a comma separated list of strings. Here in this case, of strings, because the value is a string of strings. You can do that, of course, with a colon or without. You can just write like this. You get a comma separated list of all the values related to the field name. We can do that also for price. And the comma separated list, you cannot manipulate it directly because it's not a container. You can pass it to a function. For example, to print all the vegetables, we use the function printf, the formatted string, and vegetables, and all the values related to the field name. So this is actually not one single value, it is a list of strings, a comma separated list of strings. And we use for a string the format S. And for after each vegetable, we return to a new line. So we add N, a new line. And we print, the function will print all the elements in the list. Same for the price. We can, for example, calculate the total price. We add this value plus this value. There is a function called plus. This is a function. And we give it, instead of writing, for example, 4.35, 6.5, 3.9, etc. We just write vegetables price. This is again not a single value, it is a comma separated list of values related to the price, which are numbers, these numbers I mean. So it is a list, it's not one single element. And we pass it to a function to add all the values, and we get the total price, 45.95. We can also collect the list, because we cannot manipulate it directly. We can collect it into a vector. We build the vector, temporary vector, and we call the function sum that we have seen previously, I think in practical 2 or 3. Practical 2, I think, for matrices. It will add all the values in our vector. And it gives, of course, the same value. But it's better not to build the temporary, to lose memory, to waste memory. Better directly, if you have a function that accepts a varying number of variables, that accept a list of variables, better use directly the list. If not, collect them in a vector and send it to the function sum. Function sum will not accept a list of variables. It's not possible. It accepts only one variable. It accepts a vector. It sums the element of a vector. You cannot do that. It's impossible. It's invalid, call to sum. You need one single vector. So we collect all the elements inside the vector, and then we call the sum. Or directly, as I said, we have fortunately a function called plus that accepts a list of variables. It will add all the elements in the list. We have seen the definition of a structure, how we build an array of structures, a structure array, how we concatenate it, how we append an array to another array of structures, and we have seen how we get the number of fields and their names, and how we access the value, a single value of a structure corresponding related to a field, or all the values related to a field in an array structure. Now let us apply this knowledge on the data structure to our vegetables, to our invoice of vegetables. We change our invoice using a new data type, the data type structure, not matrices as before. So let's go to the editor and save this as invoice 2, because we'll modify it. Save as invoice 2. And this is the task. This is the task. This is the task to print the vegetables, to print the invoice, and this is the data. And this is the data. So what we will do, we separate the data from the task. So task, we will put it in a function. So in this practical, we will see for the first time how to write a function. We have seen in the last practical how to write a script. Here we will see how to write a function. So we separate our task into the data. We store it in invoice 2, and printing the invoice, we will store it in a function. So let's save this. We are 28th. It's about 1 month, because I moved to Algeria. I'm now in Algeria, in my parent house. So my parent passed away, but this is the parent house. It's my room in my parent house. So let's modify the data. We have seen that here. I think we have here in the command history, we can copy paste this is our vegetables, and we have added zucchini and pumpkin. This is our data. And to print the invoice, we call a function. We have not created it. We call it printInvoice. It is an algorithm. Function actually is the implementation of an algorithm. It takes an input and it gives an output. Here we have no output. It just prints the invoice. But as an input, it takes vegetables, our structure array, our array of structures, vegetables. And its task, the function, its task is to print the vegetables. So let us create this function. So let us create a new file. Always a function start with the keyword function. Then you give the output. Here there is no output. So we give the field, the name of the function. We have called it printInvoice and the parenthesis. And here you give the output. The input, vegetables. And you end the function by end function. By end function. So this is called the header of the function. Always output equals, normally we have output equals the name of the function. The output equals the name of the function and the input. It's always the grammar of a function, of the header of the function, is always that. It's the interface of the algorithm. You have the input, and you get the output. And you name the algorithm the name you want. So in our case, there is no output. So we don't need that. And inside our function, we will write the task of printing the vegetable, of printing the data. But in the previous invoice, let us only call it, in the previous invoice, we use the data matrices. The data is stored in 3 matrices. So we copy paste this in our function, in the body of our function. This is called the body. Inside, between function, the keyword function, and end function is called the body of the function. So function has a body and the header. The most important, of course, is the body. And let's write here a comment. Let's copy paste it. And let's write here 28 November. Also in invoice 2, 28 November, Algeria, not Malaysia. And it's practical number 5, structures and cells. And let's save, before to modify, let's save our function. Here also it is important in Matlab, the function must be saved in a file having the same name as your function. The function is called printInvoice. The file must be also called printInvoice. So this is specific to Matlab. In other languages you don't need to do that, but in Matlab you must name the file where you store your function with the same name of the function. Invoice, printInvoice, and it will add M automatically. And you can see here the name of the file and the name of the function are the same. Let's close this, we don't need it. We will work with invoice 2 and printInvoice. So what we do in the body of the function, we print the date, okay, print vegetables, the padding string, how we can calculate the padding string, how we can build the padding string. We need the maximum length of the vegetables. So let's call it L. We have our vegetables stored in the field name. We cross the array of structures name by name, and we should get the maximum number of characters in each name. I mean of all the names. So we get here, for example, we have 7, here we have 6, and so on. We want to get the maximum length to use it to build our padding string. How we do that? We put L equals 0, and we cross for I equal 1 till the number of elements in the vegetables. So we cross the vegetables one by one, structure by structure, vegetables, and 4. And at each iteration, we check whether L is smaller than the number of elements in the current value of vegetables name. So the structure, the ith structure, vegetables here, the ith structure, the ith vegetable, the field name, how many elements is there, how many characters is there, or how many bytes is there in the current vegetable. If it is larger than L, then we put it in L, because we want to put in L the maximum value, the maximum number of elements, the maximum length of each name. And if. So if L is less than the number of elements in the current value of the field name, we modify it. We put that value in L. Otherwise, we skip. We go to the second and third and fourth. We cross all the vegetables, and each time we check the value of the field name, the current value of the field name. And this is the maximum length. So we use it here to build the path string. And that's it. So let's write here a comment to say that it is the maximum length of vegetable names, Okay. And here we have, in the previous data, we use a matrix. We don't use a matrix. Here we have an array, so the current structure, the current vegetable is vegetables I. And we want to print the name. And here, upon the name, okay. And here, the masses, there is no masses. It's vegetable I mass, the field mass. And then W, and there is no prices. It is vegetables I, the ith vegetable, and the field is price. So we access the field by the name. We want the field name, the field mass, and the field price for the current vegetable. We cross I, here vegetable, num of element, not size, num of element. I will go from 1 till the last number, from 1 till the number of elements in the vegetables. But the elements here are structures. So we get them with the index I, followed by the field name. Okay, so we print vegetables. For the price, as I said, we use plus, the function plus, and vegetables without an index, and the field price. So we get a list of all the values related to the field price. And that's it. Let's test it. We go to invoice. We don't run the function. We don't run the function. We run the script. The script will execute these commands. So it sets the vegetables, it appends it, and then it calls the function. The script will call the function with, this is called the argument. When you call the function and you give the input, this is called the argument. But here is called the parameter. They are different. The vegetables here is not the vegetables here. Here you can call it U, or you can call it U, for example. You can call it U. You can call it the name you want. It will take this value, the content of U, and it will copy it here. It will copy it to vegetables. So this is called parameter, and this is called an argument. There are two different objects, and this is how it works in Matlab. In other languages, it is more complex. You can copy or pass the address in memory or reference, but in Matlab, the mechanism to call a function, it copies the argument you give as an input to the parameter defining the function. When you define a function, the object used as input are called parameters. Again and again. This is a parameter, and this is an argument. They are different. You call them here what you want. It will copy the content of the argument you pass to the function to the parameter. And then it executes the body of the function, the algorithm. And it returns to the script, calling the function. If there are other instructions here, it will execute the rest of the script. This is how it works. Always it copies the content of the arguments passed to the function, to the parameters that you use to define your function. So, but for clarity, of course, we don't call it U, we call it vegetables. So let's undo here, vegetables. Albeit have the same name, but vegetables here is different from vegetables here. And always the mechanism, it is always a copy of the argument to the parameter. So let's execute or run the script. And if you have made a mistake, we have made a mistake because so everything works, but here we don't use the same width to print the vegetables. So we will modify that in the function. We don't modify the script. Script is okay. We modify the function. So vegetable here will be used with width star, and this width is L. All the vegetables will be printed in the same width, the maximum width. And then we add the padding string. And because we have width, we adjust them to the left. And we save, and we go back to the script, and we execute. And voila. Exactly the same result as invoice 1, but here the data are more sophisticated. We use structure, not matrices, because the name, the mass, and the price are related. They are not separate. They are related to vegetable. So we don't store, it's better not to store them separately in different matrices, but instead we collect them in a structure. And because we have several structures, and in general, of course, we manipulate several structures, not one single structure, so we use an array of structure. The field, the values, the second field, the values, the third field, the values, and all the values are between braces and the same number of values per each field. And then we call our function. We have modified it slightly. It's the same algorithm, but we manipulate here an array of structures, or a structure array, not matrices. So we access the field using dot and the name of the field. The name of the field here is the name of the vegetable, mass, and price. And that's it. That's it for the first part. Let's move to the second part. So before to go to the second part, the data type says, let us make two modifications to our function print invoice. As you can see here, the invoice uses the ringgit because our data the prices here are in ringgit. But let us suppose, for example, another user in Algeria, for example, or in another country, in Indonesia, or I don't know, another country, and he wants to use the same function, but the prices, of course, with another currency, a different currency. So what we will do, we add currency as a second argument. So let's call it here ringgit. In our case, it is a ringgit. This is the currency. It will be copied in the second parameter here. Let's call it currency. And another user, maybe another user can use Algerian dinar. Algerian dinar, I think, is called DZD. DZD mean Zaire dinar. DZD, Algerian dinar. DZD. But here we are using ringgit. Can use dollar or pounds or whatever. So the currency you want. In this case, because this is the good thing about the algorithm. It's the same algorithm, but you can change the data. You can use another user don't like eggplant, for example. He wants potato instead of eggplant. Mushroom, it's very expensive. He doesn't want to use and so on. The data can change from one user to another, but the algorithm is the same. Here also the currency can change. The currency is not a filter. It's the same currency for all vegetables. So we add it separately as a second argument, and here second parameter. So the nomenclature, when you use here the input, are called parameters. First parameter and the second parameter. And we look for ringgit. We have it here and here. We change that here. We use the format S. It is a string. The format S, it is a string. And we add currency just after the price. Currency. And here also currency. And we save, and we test again. And let's see what we have. Oh, correct. It replaces RM, it copy RM to currency, and it prints the currency RM. If I change, for example, DZD. Of course, the prices are different. If you change the currency, you should change, of course, the prices. But just to show you how it works, so it will copy DZ to the currency, and it will print DZ instead of RM. It prints DZ instead of RM. So this is the first modification to make our algorithm more general, not specific to people in Malaysia. And the second, I want to modify here not to print only the date, but also the hour. What we can do, there is in Matlab several utilities related to time, and one is called data string. Not date, but date string. Not data, date string. And the first argument is the time as a number. We use a function called now. Now return a number representing the current date. And here the format, how you want to format your date. I will use copy paste. I copy paste. D means the day. When it is DDD 4 times, the full name of the day. When it is only 2, the number of the day. Then the month in 3 letters, the year, the full year, 4 letters, and the hour, and the minutes, and AM or PM. You can write here PM or AM, it's the same. It will tell, it will print according to we are now in Algeria 11:06 AM. So it will write AM. And if it's the afternoon, it will write PM. So let us test it and see our invoice. So we have 11:06 AM, the date and the name of the day, Tuesday. And that's it for the first part. Let's move to the second part. So in this second part, we study cells. A cell array or an array of cells is actually a matrix whose elements can accommodate objects of any type and sizes. Not like an ordinary matrix where you can store only numbers. So all the elements in an ordinary matrix are of the same type. But in a cell array, the elements of the matrix can be of any type and of any size. And they have no names, like fields. Fields have a name. Field also you can store objects of any type and of any size, but they have names. You access them by names. However, in a cell array, you access the elements by indices. A good example of a cell array is a collection of strings. Strings are actually vectors, raw vectors of bytes, but of different sizes. You cannot store them directly in a matrix. You can store them, the only way to store them is to use a cell. So let's see how we can build a cell array and how we can access the elements in that cell array. So let us see how to build a cell array through an example. We can, for example, take a collection of fruits, which are strings of different sizes, and we store them in a cell array. So here I copy paste. We have 5 fruits: peach, pear, pineapple, plum, pomegranate. They are strings of different sizes. And we build a cell array, we name it fruits. And to build a cell array, we use parentheses, not brackets. So parentheses, and inside the parentheses, we put the strings. So B1, comma B2, comma B3, comma B4, and B5, 5 elements. And we type enter. We display the fruits. It is a cell array, a matrix of 1 row and 5 columns. So 5 elements. It's like a row vector, but it's not a vector, it is a cell array. Because the elements are not numbers, are strings, are vectors of different sizes. We have seen in section 3, if you remember, that we can actually store strings in a matrix, but that's different. If we write, for example, A equal brackets, square brackets, let's copy here, B1, B2, B4. We use concatenation, but by columns. So each column will contain a string. So 5 strings. But this is not the same, because here it's not the original string pitch. It's pitch with subsequent characters. I think here we have 11 characters. Let's check the size of A. We have 11 characters. So the size here is the same. We can store strings of the same size in a matrix. But here we have different, the original strings are of different sizes. So what we do in a matrix, we add padding characters, space characters, which is of course a waste of memory. You can consider that as a text with each line contains 11 characters and the missing characters are padded with space character. So this is not the same as a cell array. In a cell array, we store the strings as they are with their correct size. So here we have 5 characters, we store 5 characters. Here we have 4 characters, we store 4 characters. Another string contains 100 characters, we store it in 100 characters. A sentence, for example. So it is more flexible to use a cell array than a matrix whose columns are strings. So this is the difference. And the importance of, I think one of the most important application of cell array is to store strings. There is another way to build a cell array. So for example, we will use the same example. So let's clear fruits. Let's clear fruits from the memory. And the second method of building a cell array is possible only when we know the size in advance of the cell array. We know in advance how many elements we have to store in the cell array. So what we do here, we write fruits equals cell. Cell is a function that will build our cell array, and we give it the size we want. We want 1 row and 5 elements in the row. And they are empty, the cells are empty. So what we do, we access each element, the contents of the element. And here, if we do like this, well, this is the cell. This is the cell, not the string that is stored or has to be stored in the cell. We want to store strings, so we access the contents using braces, not parentheses. And we type B1. So the first cell contains now pitch. And we do the same with B2. With B3, and with B4, and with B5. So we allocate first the memory for our matrix of cells, for our cell array. The nomenclature is cell array. To say a matrix of cells, we say shortly a cell array. Like we have a structure array, now we have a cell array. So we allocate memory first, and then we assign to each cell, to the content of each cell, the string we want to store. And so be careful here, we use braces to access the content, and we use parentheses with the index to access the cell. The cell and its contents are different. So we can also check the size using, we can check the size of our cell array using size. So 1.5. We can also check how many elements, how many cells there are in our cell array. 5. And as I said before, fruits with parentheses, the first element is a string. There is a function we have seen before, isChar, to check whether the object given to it is a string or not. So we give to it, I copy paste here, we give to isChar fruits1. It is true, it is a string. But if we give with parentheses, we give a cell, it's not a char, of course. There is a function called isCell. There is a function called isCell that checks whether the input is a cell or not. It is a cell. So fruits with parentheses is a cell. So we have shown here using isChar and isCell that when you use parentheses, you are using a string, the content of the cell, the contents of the cell, or the value of the cell. And when you use parentheses, it is the cell actually, not its contents. Now let's see how we can access a group of cells, not one single cell. We use parentheses. This will return all the strings in the cells, in the cell array. So all the strings in the cells of our matrix. Peach, pineapple, plum, and pomegranate. This is actually a comma-separated list. It's not a container. It's a comma-separated list, like we have seen with a structure array. This is a comma-separated list of strings. And we can use it to call, for example, print function, to print all the strings. We use it only with functions that accept a varying number of arguments. So a list of arguments. That's exactly what printf will do with this list. It will print them. Print, I mean, the element of the list. So we use S, the format, and new line. And voila. It will print all the strings in the separated, in a comma-separated list containing the fruits. So let's clear the console and let's move to the next point. So let us see how to append a cell array to another cell array. So we have in our cell array fruits, 5 fruits. We want to append 3 others or 4 others. I have copy paste here. We use concatenation, of course. As usual, we use concatenation using the the square brackets here and here, and we start with the old version or the old value of the cell array, and the new fruits we want to append between parentheses because it is a cell array. You append a cell array to another cell array, and the result you add it, you assign it to fruits. So let's display fruits. We have now 8 fruits. Raspberry, strawberry, and watermelon have been appended. We can also append only one fruit. We don't need then braces. For example, let's append a grape. And let's display again. We have now 9 fruits. So we append a cell array to another using concatenation, like we have done with the structure array, like we have done also with strings and matrices. The same technique. Let us see how we can delete a particular cell from the cell array. For example, the third, pineapple. I want to delete pineapple. What I do, I call fruits with the cell number 3, the cell and not the content, and I will assign it an empty cell, an empty string. I mean an empty cell. An empty cell or an empty matrix is square brackets with nothing inside. And we enter peach, pear, pineapple has disappeared. And the number now is 8 fruits. We can also delete not the cell, but its contents. For example, pear. I keep the cell, but the string, I will delete it. How we can do that? We use same technique, but with parentheses. So the second string in the second cell will be deleted, but not the cell. So as you can see, the second element, the second cell, is still here. We have still 8 elements, still 8 cells, but the second string, the fruit, has disappeared. We have only peach and plum. And we can, of course, assign it again. We have deleted pear. Okay. And we get it back. We have seen what is a cell array, how to build it, either using braces, or if we know already the size of the cell array, we can use the function cell. And then we assign the content element by element. Then we have seen how we can append a cell array to another using concatenation, and how we can delete some elements from our cell array. Let us now use this knowledge on cell arrays to modify our function print invoice. So let's go to print invoice. And let's modify this part of the code using a loop for. We have seen that this part of the code is used to calculate the maximum length of vegetable names. So vegetable names. Okay, let's call it again. It will clear the memory and print the invoice. So now we have in the memory vegetables. We want to work with vegetables, not fruits. Vegetables. So vegetables is a structure array. Vegetables name is a comma separated list of strings. So a collection of strings. And as I said, you cannot work directly with a comma separated list. You can give it to a function that accepts a varying number of arguments, but you cannot work directly with a comma separate list because it's not a container. And we have just seen one important application of a cell array is to store strings of varying sizes. This is the case this is a good example to use a cell array. So let's store this list in a cell array. Let's call it U, for example. So we have now a cell array containing all the strings, all the values of name field. That is all the vegetables. And we want to calculate the maximum length. We use num element. You cannot use it directly to a string here. If you use for num element U, it is the number of elements in U. But we want the number of characters in each string. How we can do that? We do that, for example, U1. We get the number of elements or the size or the length of the fruit eggplant. So 8. There is 8 characters in the name eggplant. U2 is 6, and so on. There is a function actually to void the loop for. This is our goal, is to void the loop for. There is a function called fun cell. I mean cell function. Cell function will apply any function you give, any function f, to your cell array. So let us give it num element. A num element is a built-in function. It will not work like that. You have to add at. You have to add at. So this is the function we want to apply to each element of the cell array, to the fruits. So this is equivalent to say num element of U1, num element of U2, num element of U3, etc. All the elements, all the strings inside the cells of U. It returns a vector containing the length of each string in the cells. So return a vector 8, 6. That is the number of characters in the first string, in the first cell. 6, the string in the second cell, its length, the length of the string in the third cell, and so on, without any loop for. And our goal is to calculate the maximum. So let's repeat that and send this vector or give this vector to the function max. To the function max. Max will return, of course, 8. 8 is the maximum length. Most vegetables here have 8 characters. So the maximum here is 8. That's exactly what we have done in printInvoice. But here we have used a loop for to cross all the vegetables with the field name, and then we compare. It's very simple, very easier to use one single command to calculate L. We call that vectorization. Vectorization, you replace a loop for with a single call to a function. Here actually 2 functions we have called self-fun and then max in one single line. This is faster. This is 10 times in Matlab. This is 10 times to 100 times according to the documentation. Vectorization can make your code 10 to 100 times faster than the loop for. So this code This code is shorter and faster than this one. So we repeat it, we replace it, and we eliminate the loop for. That's the modification we have added. Now that we know cells, we can use them to collect our strings that define actually the name of the fruits. And we have used a function called cellFun. There are actually three that are frequently used in vectorization: ArrayFun, cellFun, and structFun. I'll come back to that, but let's first test that. So we have vectorized our code, this part of the code, using cellFun. So let's write here third edition or third version. Save, and let's test it again. What is U? We don't have U here. U is vegetables, vegetables, name. This is a list, a comma-separated list. We collect it, we store it in a cell array using parentheses. Let us execute, save first, and go to the script and run it. And exactly the same. But the code here is better and faster. It's not a big deal if you, when you begin an algorithm, when you are implementing an algorithm, a new algorithm, you are doing it yourself, not copy-paste. You are, and I do not advise to copy-paste. Understand an algorithm and try to implement it by yourself. So when you implement the first version, avoid vectorization. Use the loop for. Implement the idea as they are, without sophistication. And then look for where you can vectorize the part of your code that you can vectorize. And as I said, we have three functions. I write them here. Array, fun. They end always by fun. Array fun, this is for matrices. Cell fun, we have just seen it. This is for a cell array. And struct fun, this is for structure, a cell of structures. What these functions do, for example, array fun, exactly like cell array. Array fun, you give two arguments. The first is always a function. And this function will deal with the element of your matrix, the matrix A, for example. Each element, it will apply the array function, array fun, will apply f to each element of A. It's like, it's equivalent to f A1, then f A2, then f A3, and so on. All, A3, and so on, till the end element of A, till the end. So it applies f to the first element, to the second, to the third, etc., till the end. And it collects the result, because when you apply f, you get a result, an output. If that output is a number, it collects them in a matrix, in brackets, in a matrix. If not, if it's not a number, a structure or a string of different sizes, or a cell array, any type. If it is any other type that other than a number, they are collected actually in a cell array. They are collected in a cell array. And same for cell function that we have just seen in this practical. So cell function, here A must be a cell, not a matrix. So it will apply it to the contents, the value of the cell. The first content, the content of the first cell, the content of the second cell, the content of the third cell, the contents are not the cell. It applies the function to the contents of each cell till the last cell. So this and this are exactly the same. It will apply the function to the contents of each cell. And same thing if the result, if f return a number, they are collected in a matrix. Otherwise, they are collected in a cell array. And same also for struct function. Struct function. Here A is a structure. So structure is a structure array. So the elements are accessed by name. For example, I don't know, the first is called first. Let's call it first. Or the second is called second field. Its name is second. And third is called third, for example. And then on the condition, of course, that f can accept different types, the type, because the fields could be of different types. So if f accepts the type of the first, the second, and the third fields, you can use this function. And also the result, if it's a number, it is collected in a matrix. Otherwise, it is collected in a cell array. So whenever possible, you can replace a loop for using struct fun, array fun, or cell fun, like we have did. So that's it for this practical. Next time, inshallah, the sixth practical will be dedicated to algorithms. We will try to apply very simple algorithms using Matlab to learn more and to practice more the language. There will be no other data types. We have seen matrices, strings, structures, and cells. These are the major data types in Matlab. But we need more application to be more comfortable with Matlab. And then after that, inshallah, we will come back to our module, to chapter number 1. So see you inshallah next time. Peace.